Welcome to this channel. Welcome to this session. This is the teacher Isaac Tohire, a teacher of mathematics who is aiming at making mathematics simple, all easy for everyone to understand. And in these videos, we simplify the content so that everyone can understand. And we want to appreciate you so much for watching our videos. Do not forget to subscribe, like and share for more videos. Please share for the benefit of others. In this video, we are going to introduce the three-dimensional figures, but specifically we are likely to look at cylinders. And now we are going to focus on volume and total surface area of a cylinder, as you had said that we are going to look at the cylinder as one of the three-dimensional figures. So in this video, we have made cylinders easy for everyone to understand. And what you need to do is to like, subscribe, and share. When we talk of a cylinder is a three-dimensional figure with the two parallel and circular bases connected by curved lateral surfaces. Cylinders are common in everyday life, such as water tanks, pipes, bottles, cans and containers, engine cylinders, and very many others. But now, what are the properties of a cylinder? A cylinder has two circular bases with the same radius. The height of a cylinder is the distance between the circular bases. The lateral surface area of a cylinder is the curved surface that joins the two bases. Now, what are the examples of cylinders? Of course, we have here water tanks, we have some cups, pieces of chalk in glass. They are also cylindrical, or they are cylinders also. We have water pipes, we have bottles, we have saucepans, we have dry cells, we have gas cylinders, we have Vaseline tins. As you can see, there are many of them. As long as you see a shape, you come across a shape with the same circular bases, with a curved surface, then just know that it is a cylinder. An example is here. I have my cylinder here, but now this is the first base, this one, and then here down also it sits with a circular part. So you expect also here to have the second circle. Then I've said that the distance between the two circular bases is the height of a cylinder. So the moment we talk of the height of a cylinder, it is this distance, as you can see. This distance here, the distance between the two circular bases, is what we call the height of a cylinder. Also, we have some other shapes here. Also here, like this battery or a dry cell. Now I have here this first one, this first circular base, and also another one here at the bottom. So the moment they say that the height, then just know that the height is the distance in between the two circular bases. So we say that this is our H. Now here we want to look at the net of a cylinder. When we talk of a net in mathematics, we just mean a 2D representation of 3D object that can be folded to form the actual shape. Now, like as you have said that a cylinder has two properties, has two circular bases and the curved surface. And now we need to ask ourselves, if we unfold a cylinder, what do we get? And for me to make a cylinder, what do I need? As we are going to see. Now, when you look at this cylinder, it has two circles. At the same time, this rectangular, this curved surface. But now, it means that for you to form a cylinder, you must have the two circles, at the same time, rectangle. And that's why you see me having my shape here down, as you can see, the net of a cylinder. So as we are doing all our things, whenever we talk of the net, it is just a 2D representation of a 3D shape that can be folded to form the actual shape. So for the case of a cylinder, we need to be having the two circles and one rectangle. And those two circles should be having the same radius. And you can see here that as you can see that here we have our cylinder here, this first circle, another circle here, but you can see that they are of the same size. The height, as we had said earlier, that is the distance between the two circular bases. So when I unfold this cylinder, I get two circles and then one rectangle. But when I fold this rectangle, I get the curved surface. When I fold it, I get the curved surface. And then this circle will be the one on top, and then another circle will be the one at the bottom. And that's what we call a net. So when we fold this net, we get a cylinder. But when we unfold the cylinder, we get this shape, a rectangle and the two circles. As you can see also mine. Now we are going to look at the formula for finding volume and total surface area of a cylinder. But now here specifically, we want to see before you find the volume and total surface area of a cylinder, one of the things that you should know is one, a net of a cylinder. Very important. Now you can see that the moment I fold this rectangular part, this rectangle, it is the one that is going to form this curved part of the tank, of the surface. And then after folding it, I'll put one circle on top, another circle on bottom to become a complete cylinder. But now this one will be a closed cylinder, closed at closed at both ends. But if you look at cups, they have the bottom circle, but they don't have the top circle. So it means that for a cup without a cover, we shall consider only one circle at the bottom because it will not be having the one on top. So for the case of an open cylinder at one end, it will have a rectangle and one circle. Now this is our cylinder, this is the height, then this is the radius. So the lateral surface area, as we have said in properties, is the area of the curved surface. Lateral surface area is the curved surface. So for the case of curved surface, as I've told you that whenever you fold this rectangle here, what you form the curved part. And so we are going to put the two circles, one at the bottom and another one on top. So that means that now that the circle is fitting on that curved part on top, then it means that the length of this rectangle will be the circumference of this circle. And then the width of the rectangle will become the height of the cylinder. Will become the height of, so we shall have the length as the circumference of a circle, that is 2 pi r or pi d, and then we shall have the width as the height of a cylinder. So it means that the lateral surface area, or the area of the curved surface, will be the length of a rectangle, which is the circumference of a circle, times the width of the rectangle, which is the height. So that's why here you are seeing us having 2 pi r h, whereby 2 pi r is the length of a rectangle and h is the width of rectangle. So total surface area is 2 pi r into h plus r. And then for the case of volume, volume is equal to base area times height. But the base of a cylinder is a circle. A cylinder has a circular base. And how do we find the area of a circle? The area of a circle is equal to pi r squared. And now whenever we come here and we say that area of a circle is equal to, so area of the circle is pi r squared, then times h, then we get our formula as pi r squared h, the one we are seeing here. Then area of the curved surface, as I've told you, that it is the circumference of the circular top or bottom. Remember, we have said that they have the same radius times height. And then that's why you are seeing as the area of the curved surface as 2 pi r squared h. I've said that this 2 pi r squared, this 2 pi r stands for the circumference of a circle, and then h stands for the height of a cylinder. Now, whenever they ask us total surface area of a cylinder, we have said that a cylinder has a rectangle and two circles. But this rectangle is the curved surface. So we shall come and we say that total surface area is equal to area of the curved surface plus area of two circles. These two circles only apply to a closed cylinder at both ends. If we have a cylinder open at one end, then we consider only one circle. And for the case of pipes which are hollow, then you expect to just consider the area of the curved surface, because it will not be having a circle at the bottom at the same time on top. But for the case of a closed cylinder, we shall consider the two circles. So this is so we shall say that area of the curved surface is, or lateral surface area, is equal to 2 pi r h times The area of one circle is pi r squared times 2. We get 2 pi r squared. And here, senior 2 you learned about factorization. I can see here 2 pi. I can also here see 2 pi. I have r and then here I have r. It means that now here the common factor is 2 pi r. So the moment I pull out 2 pi r, I get here I remain with h and then here I remain with r, because r times r I get r squared. So even if you open your brackets, still you get back to this step above. And still you can see that those are the formulas that I have here, 2 pi r squared plus 2 pi r h. But this only works for a closed cylinder. I repeat, if it is open at one end, then we shall consider one circle. But if it is closed at both ends, then we expect to use the two circles. So we have here our examples, and example number 1 says a cylindrical tank closed at both ends has the diameter of 42 centimeters and the height of 100 centimeters. The task is saying work out the volume of the tank and its capacity. First of all, we have said that volume of, and then here we have determine the total surface area of a tank. First of all, you have to draw this tank. As you have said, that diameter, that means that this is the distance. Diameter is the distance touching 2 points on a circle. So you can see that I have my circles, 2 circles. Then I indicate my height here is 100, and then my diameter as 42 centimeters. Say that height is the distance between the 2 circles. That's why you're seeing me putting here 100. But now we have said that volume of cylinder is equal to base area times height. You can see that the base is circular. So we shall say area of a circle times the height of a cylinder. So here we shall have pi r squared in h. And now I'm going to ask myself, what is pi? I'm going to take pi as 22 out of 7. If they have not given you pi to be 3.142, then it's better you go for 22 out of 7. And now that the diameter is 42, so it means that the radius will be 21, because the diameter is twice radius, and radius is a half diameter. So a half of 42 is 21. So that's why here we are having pi 22 out of 7 times radius, which is 21, times 21, then here times 100. R squared is not the same as R times 2, but is R times R. That's why you are seeing me having 21 times 21, that stands for R squared. And the moment I multiply this on my calc, I end up getting 138, then 600 cubic centimeters. And remember, volume is measured in cubic units. Then also total surface area, we have said that now that this is a closed tank, so we expect to consider the 2 circles. So volume of it, total surface area of a tank is the area of the curved surface or lateral surface area plus the area of 2 circles. And here we have 2 times 20 out of 7 plus 21 times 21, then times 100. Then now this is the area of the curved surface or lateral surface area. Then plus 2 times 22 out of 7 times 21 times 21. And here we get 13200, and then plus 2772 square centimeters. And here we shall have 15972 square centimeters. This is the total surface area, and total surface area is As long as you hear area, then just know that you have to give your answer in square units. But also here they asked us capacity. They asked us here capacity, and now here you must be very, very, very careful when you come to capacity. The moment they ask liters, then just know that you'll be finding the capacity of a tank. So the moment you see capacity, then just know that you are finding the number of liters that the water tank can hold. So here we shall come here and we say that capacity is equal to 1 liter is equal to 1,000 cubic centimeters. 1,000 cubic centimeters. 1 liter is equal to 1,000 cubic centimeters. So when you have your volume in cubic centimeters, you get that volume divided by 1,000 to get the capacity in liters. So our volume has been this 138600 cubic centimeters divided by 1,000, we get 138.6 liters. But here volume should be in cubic centimeters for you to divide by 1,000, because 1 liter is equal to 1,000 cubic centimeters. Then we have also our examples. We have example 2, and a certain village has bought a metallic tank of diameter 7 meters and height of 10 meters to help them during dry season. They always sell water using 20-liter jerry can at 1,000 shillings each. The tank has faded due to too much sunshine, and they would like to paint the top circular part and the curved surface. They are planning to buy 5-liter tins of paint each, sold at 45,000 shillings, and each tin can paint 25 square meters, but they don't know the number of tins and amount of money needed for painting. After painting, the chairperson of that village wants to wrap a sticker around the tank from the base to the neck to protect it against sunshine, as well as informing people to buy clean water from the tank, but is not sure of the size of the sticker to use. And now task number 1, they are saying determine the capacity of the tank. As we have said, that capacity is volume divided by 1,000, but volume should be in cubic centimeters for you to divide by 1,000. Then we have also how much money will be got from selling water from the full tank. Then lastly, they are saying determine the surface area to be painted. And then part D, find the amount of money needed to paint the tank. And then lastly, calculate the size of the sticker needed to be wrapped around the tank. Make sure that you subscribe, like, and share. Now, first of all, we have said that total surface area of a cylinder is 2 pi r squared, then plus 2 pi r h, and volume of a cylinder is pi r squared h. Now, when you read a scenario, make sure that you extract the important information from it. Here, the diameter of the tank has been 7 meters, then the radius has been 3.5 meters, then the height of the tank has been 10 meters. But for you to find the capacity, then it means that you have to find the volume in cubic centimeters. Now that volume, here our dimensions are in meters, it's better I change them to centimeters. 1 meter is equal to 100 centimeters. That means that the diameter will be 700 centimeters, and radius now will be a half of this diameter of 700, that is 350, and the height now is 10 times 100, I get 1000 centimeters. And also they have said that each jerry can, they were selling water using 20-liter jerry cans. And now part A, we are going to find the capacity, but we cannot find the capacity without volume. Volume is equal to pi r squared h. So I have pi as 22 out of 7 times 350 the radius times 350 radius times 1000. R squared, students, is not same as r times 2, but is r times r. That's why you are seeing me here again emphasizing that, because that is mistake is mostly done by students. R power 2 or r squared, they get 350 times 2, but it is 350 times 350. And here the answer is 385 million cubic centimeters. Now, after getting my volume in cubic centimeters, I can find the capacity by dividing that volume by 1000. So here volume capacity is equal to volume divided by 1000, and the capacity is in liters. So when I get this, I divide by 1000, I get 385,000 liters. Then part B was saying how much will they get after selling water from a full tank. But there is no way how you can find money that they will collect when you have not known the number of jerry cans collected, the number of jerry cans got from that tank. Remember, we are saying they use 20-liter jerry cans to sell water. So it means that you have to get the liters, the capacity of the tank divided by the capacity of a jerry can. How many liters does the tank hold? And how many liters of water can be in a jerry can? Then the moment you get the capacity of the tank divided by the capacity of the jerry can, you'll get the number of jerry cans. And here you can see that our capacity of the tank is this. And then divided by 20, we get 19,250 jerry cans. And then amount of money that we shall get. We'll get one jerry can costs 1,000. Then 19,250 jerry cans will cost 19,250,000 shillings. Please don't forget to give a conclusion. It is very important. You must give a conclusion. Now part C, they were say find the painted surface, the area of the painted surface. First of all, we have said that the area of the curved surface or lateral surface area then plus the area of now one circle. Because when a tank is sitting on its on a ground, we don't paint that part, but we paint the curved surface and also the part, the top circular part or the top circle or the cover of the tank, but we don't paint its circular base at the bottom. So that's why here you are seeing me now considering only one circle, as we had said. Then here, the lateral surface area is 2 pi r h, then plus pi r squared. And after, you can see that this is 2 times pi times r 350 times 1000, then plus 22 times 350 times 350. Then here we get the answer now as 2,585,000 square centimeters. Then our last part is, what is the size of the sticker that will be wrapped around the tank from the base to the neck of the tank? It means that now the sticker will not be on the circular top or the circle on top. At the same time, it will not be on the base, because the base will be on the ground, and then the part up will not be also wrapped, because we need just that curved surface. But remember, I have here my area in square centimeters. And now here you need to ask yourself, how much will someone need for painting? How much will you need for painting? But you need to find now the total, okay, that the surface area to be painted. All here, you are going to first change now this centimeter squared to square meters squared, because they are saying that every one tin can paint, 25 square meters. So it would be of a great importance for you to first change your surface area from centimeters squared to square meters. But 1 meter is equal to 100 centimeters. It means that 1 meter squared is the same as 1 centimeter, 1 meter times 1 meter. 1 meter squared is equal to 1 meter times 1 meter. But 1 meter is 100 times 100, I get 10,000 square meters. So here we'll get my answer as this 2,585,000 square centimeters divided by 10,000, and I'll get my answer as 258.5 square meters. Here they have told us that one 5-liter tin can paint 25. So to get the number of tins to paint this surface, I'll get this surface divided by what one tin can paint. And here we get the answer. When we get to 58.5 divided by 25, I get the answer as 10.34. But you cannot buy half tins. No. So now you approximate. You don't take 10, because now there is a certain surface that will remain unpainted. So it would be better if it is 10.34 tins, then we approximate to 11 tins. It's better to have much than having less. If the paint remains, no issues. But if the aim is to paint the tank and then you leave some parts not painted, it will not make sense. So it's better you take a value greater than what you have got, not so big. If it is 10.34, you cannot buy a half a tin. Now you just buy 11 tins. But one tin is 45,000 shillings. Then what about 11 tins? It means that 11 tins will cost 11 times 45,000 shillings, and I'll get my answer as 495,000 shillings. Then part E says, thus find the size of the sticker wrapped around the tank. You have seen different things, Vaseline, with the stickers wrapped either halfway that curved surface, or wrapped round it. So the moment they say that find the size of the sticker wrapped round the tin, if it is covering the entire curved surface, then find the area of the curved surface or lateral surface area. But if it is covering like a half, like some Vaseline, I see Family Care covering a half, I see even some Vaselines covering a half or covering a quarter. Now, you get the total surface area, the lateral surface area, and divide by 2, you divide by 4, depending on what the question is saying. So here the area, the lateral surface area is equal to pi r h. Remember the other rectangle, that the length becomes the circumference of a circle, and then the width becomes the height. Then we have here our pi as 20 out of 7, then our radius is 350, and then our height is 1000. But all these are in centimeters. And here we get our answer as 2,200,000 square centimeters. Thank you so much for watching, and we meet in the second video. I hope this video has helped you to understand cylinders better. Do not forget to subscribe, like, and share.